Welcome to EPG Pathshala. Our today's topic is Mobile IP, which is module number 27 for the paper Mobile Computing in the subject Information Technology. The topics which I will be discussing today are Introduction to the Mobile IP Technology, Motivational Scenario for the use of Mobile IP Technology looking at today's context, Need and Requirements which are to be followed by the Mobile IP Technology, the basic components which form mobile IP infrastructure and the working of mobile IP technology. To begin with, let us observe the motivational scenario for the need of mobile IP technology in today's context. In 2008, Mary Meeker, an internet analyst from Morgan Stanley, made a very bold and ambitious prediction. She said, "Mobile will overtake fixed internet by 2014. We all are experiencing the power of this prediction." As per statistical facts, the mobile internet penetration worldwide was 73.4% in 2013 and is expected to go beyond 90% in 2017. We are living in anywhere, anytime computing world. Mobile phones are computers now. They are seeking services, they are providing services, they are servers themselves. The mobile computing devices using internet are transforming themselves from the naive mobile phones and laptops to the very specialized satellites, routers on board aircrafts, vehicles themselves acting as nodes, wearable devices and many more. In such a scenario, mobility management is a very important aspect both for telephony as well as for internet and other networks. Mobile computing demands a seamless supply of services and uninterrupted network connectivity to the devices on move. With the goal of providing mobility on internet, mobile IP was developed by IETF, that is Internet Engineering Task Force, and was documented in RFC 3344, which is revised as RFC 5944. Mobile IP comes with the assurance of providing inter-network connectivity to the mobile phone without changing their IP address. How is it possible? It is in total contradiction with the working of TCP. The point of attachment of a reliable TCP connection is a socket. Socket consists of port number and IP address. Port number specifies the application to which the packet is to be delivered, and the IP address identifies the device on the internet. For a stable TCP connection, the port number and IP address of the sender as well as the port number and IP address of the receiver should remain intact. This works well when the device is stationary in a particular network. But what if the device is moving from one network to another network? The socket pair consists of port number and IP address, of which port numbers are application specific, they do not change, but the IP address change. Why? Because when the device moves from one network to another, having a subnet different from the previous network, the network portion of the IP address will change. The IP address, as we all know, consists of the network portion as well as the host portion. So, when the device moves from one network to another network, the network portion of the IP address change. When the network portion of the IP address changes, the socket pair changes, TCP connection is lost, the packet will not be delivered to the device. So, what is the solution to it? One of the immediate solution to this problem is DHCP. Using DHCP, a new IP address should be assigned to the device when it moves to a new network so that the packet can be forwarded to that address. But this new address will not be noticed through the network and device will not be found on the internet. One way to handle this was offered in RFC 2136, which suggested mapping of IP address with the help of dynamic DNS. But dynamic DNS does not work when the mobile devices are moving too frequently. DNS needs some time to update the internal tables necessary to map the logical name to IP address. This approach does not work when the mobile device moves too frequently. because DNS uses caching to improve scalability and frequent updating will be very expensive. Another option can be to change the routing table to create specific routes to the mobile nodes. It is not at all possible practically to change the routing tables as it may be a threat to the stability. Therefore, there is a need of more general architecture leading to the evolution of mobile IP. The term mobile in mobile IP signifies that all the connections are maintained even if the point of attachment changes from one location to another location. How it is done? Before looking into the working of mobile IP, let us imagine a similar real-time scenario which we experience in our day-to-day life. The solution to that scenario is the basis on which the mobile IP stands. The scenario is like this. A person is having a permanent address in a city, but due to the job requirements, he moves from one city to another city. Now, obviously, when he will be moving, he will try to acquire a place to live in those cities. Those are the temporary addresses for that particular person. Now, if anyone wants to communicate with that person, how he should communicate? Should all the temporary addresses as the person is moving be available to the person who want to contact him? It will be a threat to the privacy of that particular person, and also it is not possible to notify the change in temporary addresses if the person is moving too frequently. So, what is the solution? One solution is that the person should have two addresses, one permanent address which is of his home and the another temporary address where he is residing currently. Now, if his friend wants to send a letter to that particular person, he will be sending to his home address only, because that is the address which is available to all. The temporary addresses are not available to anybody. The letter reaches the person's home. Now, any person there like his father or his guardian will take that particular letter. On the envelope, he will find the name of the person as the destination. He is also well informed that the person is not in his home and he has to forward the letter to his current location which is known to him. But can he change the address on that envelope? That is not good at all. What he will do is that he will take another envelope, write the name of the person as destination, write the name of the source as his own name, put the older letter in that particular envelope and forward it to his current location. When the person receives the letter at his current location, he will take out the letter from the outer envelope and read the letter which is present in the inner envelope. This is exactly what mobile IP uses. Instead of using one fixed address, it uses two addresses. One address is fixed, that is the address by which the mobile device was configured at the time he was connected to the network. That is known as the home address. Another address is known as care of address, which is the temporary address the mobile device acquires when he enters into the foreign network. A packet intended for the mobile device who is not currently in the network will be forwarded to the care of address using the mechanisms which we will be discussing shortly. Let us see the requirements which the development of mobile IP as a standard should follow. Some of them are: first, compatibility. Whenever anything comes into the market, it brings change, but that change should be compatible with something which is already existing. The same thing applies with mobile IP too. Mobile IP should be compatible or at least should be integrated with existing operating system applications and network protocols. It should not demand much changes in the router software and should be compatible with the lower layers of fixed IP. It should be able to communicate with the devices which are not using mobile IP. The addressing format, the routing schemes should be same so that the device can access all the other server and systems in the internet. The second requirement is non-transparency from the higher layers. The mobility of the node, the change in point of attachment should not be visible to the higher layers of the network layer. What is the reason? The reason is that those higher layer will start behaving accordingly to the change point of attachment. For example, TCP, when it observes the change in point of attachment, will try to change the port numbers also. Changing the port numbers will result in change in the socket pair. The change in socket pair will lead to the loss of TCP connection, and which ultimately lose all the reason for which the mobile IP has been designed. The third requirement is quick re-establishment. We said that mobile IP was designed to provide seamless supply of services and uninterrupted network connectivity. But actually the fact is that when the device enters a foreign network, it faces a small disconnections for the time period for which it realizes that it is in the foreign network, it achieves a care of address, it registers the care of address with the home agent. The revival from this disconnection should be fast enough. Why? Because a TCP connection can sustain or survive from a short disconnection, but not from the longer ones. Another requirement which the mobile IP protocol should follow is scalability. As the number of mobile devices are increasing, the mobile IP technology should also be scalable on all the devices worldwide. Efficiency. It should not adversely affect the efficiency of existing network. Last but the most important requirement is security. The mobility of the node should not be transparent to the other nodes in the network, otherwise it will be threat to the attacks. That is why the addresses are encapsulated when they are forwarded to the care of address of the mobile node. Proper authentication measures should be made to ensure that the packet intended for the mobile node reaches it and not to any other node. Authentication processes should also be followed during the registration process to make sure that malicious node do not disrupt the traffic between the mobile node and the home agent by sending fake or bogus care of addresses. So, these are some of the requirements which the mobile IP protocol should follow. Now, let us look at the architecture of mobile IP technology. The following entities have been defined in mobile IP architecture as described in RFC 3344. The first entity is of course the mobile node. It is the endpoint which can be a phone, a laptop, a vehicle, a router which moves from one subnet to another, changing its point of attachment. The second is correspondent node. Correspondent node is the device which wishes to communicate with the mobile node. It itself can be fixed or mobile. It sends the packets to the mobile node which may be in its home network or in its foreign network. The third entity is home network. It is the subnet of the network to which mobile node belongs. Fourth entity is foreign network, subnet of the network in which the mobile node currently resides. Fifth, the home address, original IP address of the node which is known to all as the identity of the node. It is assigned to the mobile node at the time when it is configured with the home network. Care of address. Care of address is a temporary address which the mobile node acquires when it enters into a foreign network. Care of address can be one of these two. It can be a foreign agent care of address in which the address assigned to the device is that of foreign agent. It can also be an independent care of address achieved by the mobile node by using DHCP. This type of care of address is known as co-located care of address. Looking at the scarcity of IPv4 address space, the foreign agent care of address are more recommended. Home agent. It is a router on a mobile node's home network which forwards the data packets to the mobile node when it is in the home network or when it is in the foreign network. One of the possible locations for the home agent can be: first, it can be a router in the home network, but this is the most appropriate location, but it requires changes in the software of the router. It can be any arbitrary node in the subnet. The problem associated with this approach is that data packet has to cross the router twice when mobile node is in the foreign network. There may be possibility that there is no home network at all. Here the router is home agent, but it is just a manager for virtual home network of the mobile node. So, till now we have discussed about the basic components which form the mobile IP infrastructure. Let us see how mobile IP behaves when the correspondent node is fixed and the mobile node is in its foreign network. The correspondent node is the sender X. He wants to communicate with the mobile node A, which is currently in a foreign network. The correspondent node knows only the home address of A. So, he sends the packet with destination as home address of A and source as its own address. The packet is received by home agent of the home network of A. Home agent is well informed that the mobile node is not in the network. He is also aware of the current location of the mobile node. The home agent encapsulates the original packet header inside a new packet header. The destination address of the new packet header will be the address, the care of address of the mobile node, and the source will be the address of the home agent itself. The packet is forwarded through a tunneling mechanism. The packet reaches the foreign network. Now, in case if the care of address is a foreign agent, the endpoint of the tunnel will be the foreign agent. It will take the packet, decapsulate it and deliver the inner packet to the mobile node. If the care of address is of mobile node itself, the endpoint of the tunnel will be the mobile node. It will take out the inner packet from the outer packet header and the packet will be received by the mobile node. When the mobile node wants to give back response, the response will be sent to the foreign agent and the foreign agent will deliver the packet to the correspondent node. Mobile node will continue sending and receiving packets as if it was in a fixed network. That is the beauty of mobile IP. Let us look at some other cases. One case is when the correspondent node is fixed and the mobile node is in the foreign home network. In this situation, the correspondent node will send the packet to the home agent. Home agent, knowing that the mobile node is in the home network itself, will deliver the packet to it. Second situation, when the correspondent node is mobile with the agent HAC and mobile node is in the home network with the agent HA. The correspondent node sends the packet to its own home agent. Its home agent will relay the packet to the home agent of mobile node and the mobile node will send the packet and the home agent will send the packet to the mobile node. In short, only the home agents of the two networks are communicating. The correspondent node and the mobile node are not sharing packets among themselves directly. The third case, when the correspondent node is mobile but in foreign network with FAC as the foreign agent and mobile node is in its foreign network. The correspondent node sends the packet to its foreign agent. The foreign agent relays the packet to the home agent of the mobile node and the home agent delivers that packet to the mobile node. And the last case is a bit typical one, when both the correspondent nodes and the mobile nodes are in their foreign network. Now, the first situation is the first step is that the correspondent node will send the packet to its foreign agent. The foreign agent will send the packet to the home address of the device, which will be received by its home agent. Now, home agent knows that the mobile node is not in its network. So, it will relay the packet back to the foreign agent in which the mobile node currently is through tunneling. The foreign agent will deliver the packet to the mobile node. So, this is how mobile IP works. So, in this module we have discussed about the basic requirements and the need of mobile IP technology, the constituents of mobile IP infrastructure and working of mobile IP technology under different scenarios. The working of mobile IP technology is actually an umbrella of lots of activities, like how the mobile node identifies that it is in a foreign network, how it searches for the foreign agent, how it acquires a care of address, how it registers that care of address to its home agent, and how tunneling and encapsulation is done. So, all these activities are performed under 3 phases: discovery, registration and tunneling. These 3 phases we will be discussing in detail in the next module.